Hey, my name is Mike. I'm an engineer that works on the cloud product here at Readyset. Today, we're going to go through the process of getting set up with a Readyset cluster. Starting from the AWS Marketplace, we will create a cluster and take you through to caching your first query. So when I'm on the Marketplace here, all I need to do is just search for Readyset, and we will be able to see a list of the product offerings that we have. They're essentially just Readyset clusters that are differentiated by size. So if I scroll down and select one of those here, I will be able to view the purchase options and get the contract going for a medium-sized cluster. When I get to this page, it allows me to choose the number of clusters that I want. So if I'm making more than one for, let's say, one for development environment, one for production, I can select two. But for the purposes of this demo video, we will just create one. So I'll go ahead and create the contract. It's going to confirm if I want to pay. While the contract is getting set up in the background, you can still set up your actual Readyset Cloud account at this point and start creating your first cluster. So now when I get to this page, it's allowing me to use an organization that gets created for me automatically upon signing up through the marketplace. And that organization would be the one that is not your personal one, but the one that represents your company. So for me, it's Readyset. And here you can see that the subscription has been added because this is the first time that I've logged in. So this is what will allow me to use the medium-sized clusters once logged into the platform. So once I'm fully signed into the platform, I'm logged into my organization, what I can do is I can officially create caches. So we're going to go to create cache. We're going to use my own database, not do a demo. And then as you can see here, I can actually select from the list of products that I've purchased. So let's go with the medium clusters and we'll give our cache a name. Let's just call it demo cache. And this is important. In order to properly deploy your cluster, you have to select the same region in which your upstream database is deployed. So we currently work with both RDS and Aurora running Postgres, but MySQL is coming very soon. And I have an RDS instance that is deployed in US East 2 right now. So once we select the cluster type, the region, then we give it a name, we continue, and then we're going to be prompted for our database connection info. So now we've got our connection information filled out. Just some more information here. This is going to be created using a public cluster. In a real production scenario, we would be deploying into a private VPC that will connect from the upstream database to Readyset through VPC peering. Also coming soon is the ability to deploy directly into your own private VPC in your AWS account. But for now, it's just going to be public, and we will go ahead and create cache. So now the cache is getting created, and keep in mind that when you purchase a contract with Readyset, you're getting a high availability solution out of the gate. So there's always going to be at least two instances, no matter what size you choose, whether it's small, medium, or large. And this is just so that we can essentially have it to where the deployments always keep a running instance in case we need to upgrade Readyset or if one goes down, that sort of thing. So now we're going to be getting a bunch of information about the cluster being created in the background. So while this is happening, let's actually go over to our RDS instance and run a benchmark on a query so that we can compare the performance of that to the cache performance once the Readyset cluster comes up. Okay, so what I'm going to do now is connect into my RDS system on its own. I'm going to just input my password here. And now I'm connected to just my regular Postgres RDS. And what I'm going to do is I'm going to enable timing so we can see how long things take. And then I'm going to use this query that I've pre-selected here. This is basically going to give us a count of the number of movies in this IMDb data set in which they were released between the years of 1950 and 2000 that have greater than 1,000 votes/reviews in this data set. So the IMDb data set is basically just storing the number of votes, what the ratings were, and what year the movie was released. So when I run this query, we can see that it took about 182 milliseconds. So this is our baseline that we're working with here, 182 milliseconds against the upstream database directly. So now if I come back into Readyset Cloud, I can actually see that my cluster has come up. And what we're going to do is we're going to connect directly into our cluster so that we can run this query against Readyset itself. So I can copy the connection string and then I can actually paste it over here. I actually have the connection string copy pasted without the password. What will happen is you'll be prompted to input your password. So again, you can see that I'm actually connecting to the load balancer now. And if I connect in and then I go ahead and run the exact same query, we're going to enable timing again. And then we run the query, and we'll see that we're getting 220 milliseconds. This is because there's some variance and we have not cached the query yet. Once we cache the query, we'll be able to see the performance improvement. But first, you need to send the query to Readyset in order for it to register that it exists. So if we actually go over, now that we've run the query against Readyset directly, if we come back into the cloud here and we go to the queries page and we go to the proxy queries section, we can see that Readyset now registers that this query exists. So we can actually directly cache it from here. So let's go ahead and cache the query. Then when we come back over to the cached query page, we can see that the query has been successfully cached. Great, so now our query's been cached and we are back on the terminal that's connected to the Readyset load balancer. And so if we fire this exact same query again, sorry, we lost connection to the server there, but if we fire the exact same query again, we can see that our performance has been increased dramatically. So we started at 180 milliseconds for this query, and now that it's cached, it is down to 33 milliseconds. It is a very, very strong performance increase. So one more thing that I wanted to demonstrate here is if you see this count here, we have 12,850 rows being returned for this query. So I just want to demonstrate that, if we were connected to this load balancer as an application, and let's say that we were actually to insert some rows into the table here. So if we insert another movie that was released in the year 2000, it has 4,500 votes. And then we go ahead and run this select count again. We can see that we're getting 12,851 now. So this essentially is demonstrating that we're connected as an application to Readyset, and we give an insert to it, and it automatically replicates that data to the upstream as well. Another way of putting it is that with a lot of other caching systems, you have to worry about the TTL, or the time to live, before the cache gets invalidated. That is no longer a concern with Readyset. Well, that about concludes our demonstration for today. The Readyset Cloud product is live on the AWS Marketplace. If you're not ready to purchase a contract just yet, you can get our free 30-day trial by going to readyset.io. Or if you have more questions, you can reach out to us directly at sales@readyset.io. Thank you again so much for your time.